Construction of this aircraft was well underway when the year 1955 began. 6 production model C-130s were already under construction in January. At that time, the first plane, serial number 3001, occupied position 2 on the production line. The aircraft soon was moved to the final assembly position. A check was made to see that the actual weight of the engine, an Allison T-56, met specifications before installing it on the plane. In the meantime, Curtiss-Wright propellers were uncrated, reversible blades were fitted into the hubs, and operation of the blade change mechanism was checked. A preservative was added to the engine fuel system until actual engine runs could be accomplished on the flight lines. The engines were turned by air-ground power for the pickling process. All engines were installed by mid-February. Before the plane left the production line, installations of personnel seats and equipment were checked and found to be satisfactory. The seats were removed and special first flight test equipment was installed. The first aircraft was then moved to the engineering flight test department for flutter and vibration tests. By late March, fueling operations and tests had been completed on all engines. High-speed taxi runs were made to check the operation of different systems and equipment preparatory to flight. The first production C-130 took off on its maiden flight on April 7, 1955. Only about 800 feet of runway were required for the takeoff. The plane was in the air 1 hour and 7 minutes. During this flight, landing gear and stall tests were satisfactory. Starting with this trip, a half dozen C-130s logged a total of 94 hours and 17 minutes in tests during the remainder of the year. The landing on the first flight was routine. Using reversible propellers, the plane required only about 2,000 feet of runway for the landing. On a landing a few days later, however, a fire developed resulting from the failure of a fuel quick disconnect behind engine number 2 firewall. After the aircraft was repaired, more test flights were conducted. While number 3001 went through production, pre-flight, and engineering flight testing, static tests were being performed on airplane number 3002. The second aircraft had been designated as a static test article, a guinea pig for experimental purposes in the C-130 program. The fuselage of the static test article was prepared for an air pressure test. It was filled with containers to protect against serious damage should the section fail. The aft section failed at 12.74 pounds per square inch. To reduce potential damage resulting from pressure tests, Lockheed proposed that further tests be conducted hydrostatically. The Air Force concurred. A concrete pool was built for the hydrostatic or underwater tests of the aft and nose sections. The pool cost approximately $20,000, and the water method has saved an estimated $500,000. The water testing procedure was simple. The fuselage section was bulkheaded, made watertight, filled with water, and submerged. The interior was pressurized. With the conventional air pressure test method, when failure occurs, the force of the exploding compressed air causes secondary damage, which sometimes makes it difficult to find the origin of the weakness. Damage to the section is less in the hydrostatic test, since water, for all practical purposes, is not compressible. The forward section was pressurized satisfactorily. The aft section, which failed in the air pressure tests, was replaced and submerged in the pool. The section was successfully pressurized to 15.1 pounds per square inch, more than twice the normal operating pressure. Due to the uniformity of the center fuselage section and as a result of some previous testing at the California Division, it was considered safe to test this section with air. The section was pressurized to the required 15 pounds per square inch. The outer wing flaps were subjected to extensive fatigue tests. As weaknesses were observed, designs were improved until the flaps successfully completed 8,000 cycles. When tests began on wing down bending, it was necessary to use stop-motion photography to speed up the slow bending of the wing. The jumpy movements of the workers were caused by this camera technique. The slowly bending wing withstood ultimate load for 3 minutes without failure in the test for dynamic taxi, a condition critical for the outer wing panel. It also withstood ultimate load during the test on wing down bending and main gear load, a condition critical for the wing and main gear combination. A number of other tests were performed in an effort to improve the design of the C-130. Among these were the lateral gusts on the aft fuselage, including simulated airdrop, that is, with the cargo door open. The J2 door test, the tail-down springback test, and the test on the cam followers on the flaps. When the examinations disclosed any weaknesses, improvements were made until the parts were satisfactory. Separate tests were conducted on many vital parts of the C-130. For instance, the hydraulic reservoir was filled to capacity with fluid and slashed and vibrated simultaneously for 25 hours, simulating the most severe operating conditions. There was no leakage. During the year, special tests were made on a new cargo floor design. The new floor was constructed of extruded stiffeners riveted to a metal skin, which could be used to replace the solid machined stiffened panels in event of need for wartime acceleration of the C-130 program. The rolling test consisted of a rubber tire under a load of 6,500 pounds, rolling back and forth across the floor 2,000 times. Operation of the main landing gear was observed under extreme temperature and environmental conditions and was also subjected to sand, frozen mud, and salt spray. Temperatures range from -65 to +160 degrees Fahrenheit. This tandem landing gear is designed to enable the plane to operate safely from semi-prepared landing fields. While the static test article was undergoing many rigorous qualification tests, other C-130's completed production airplanes were used for flight tests, demonstrations, and briefings for key military personnel. The first show was staged in July. Military personnel, newspaper reporters, photographers, and top television and radio people from all over the nation came to Marietta to see the new air freighter. The demonstration began with an exhibition of the flying characteristics of the Hercules. The turboprop C-130 is the fastest transport plane in production for the U.S. Air Force. It can travel at speeds of more than 370 miles per hour. A fast climbing aircraft, the C-130 can reach an altitude of 2,500 feet in only 60 seconds. A versatile plane, the C-130 can fly with the Stratojets at 40,000 feet altitude on long missions, or it can dip low enough to drop paratroops and supplies to advance military base operations. The reporters, television, and radio men watched the Hercules back up over great distances. The unique ability to travel such distances in reverse makes the plane particularly useful in combat zones where time and space are limiting factors. The steerable nose wheel and the reversible propellers allow the aircraft to park in a very limited area. The writers and military personnel saw a display of the loading capabilities of the cargo transport. Men from the 18th Air Force, Donaldson Air Base, South Carolina, staged the demonstration. A 5,000-gallon jet fuel tanker was driven into the aircraft using the built-in loading ramp which serves as a rear door. This ramp also can be put at truck floor level for straight-in loading. The plane can accommodate 20 tons of heavy equipment. The changeover from cargo to personnel transport can be accomplished in a matter of minutes. 92 troops marched into the airplane during the demonstration. The C-130 can make either aerial or ground deliveries of men and cargo. In November, the C-130 presented a demonstration of loading general cargo at Dover, Delaware for the Military Air Transport Service. A training program was inaugurated to prepare men to become crew members of this prop jet plane. Spare parts shipments to the Air Force commands, which are to receive the C-130s, were ahead of schedule. The Air Force decided to change from Curtiss-Wright propellers to Aero Products propellers. Aero props were installed on engine number 3 of the 6th airplane, and tests were begun late in the year. The cargo transport is to be used as a supply ship in the Arctic regions. Development design was started on a ski wheel for the C-130. The ski wheels were scheduled to be flight tested late in 1956. In preparation for flights into snowlands, the tail of the C-130 was painted red, the standard Arctic marking. The color makes the aircraft visible against a background of snow-covered or even desert terrain. The testing and production programs were on schedule at the end of the year. 12 C-130s had been completed. Some were released to the Air Force for testing. Airplane number 3018 was starting on production line. Climatic, aerial delivery, desert, wind tunnel, and Arctic tests were scheduled for the next year. A highlight of the year came when the Hercules made its first extended flight, flying from Marietta to Philadelphia for the National Air Show. By late 1956, the new versatile cargo transport was scheduled to take its place as an operational unit of the United States Air Force. Assembly position. A check was made to see that the actual weight of the engine, an Allison T-56, met specifications before installing it on the plane. In the meantime, Curtiss-Wright propellers were uncrated, reversible blades were fitted into the hubs, and operation of the blade change mechanism was checked. Construction of this aircraft was well underway when the year 1955 began. 6 production model C-130s were already under construction in January. At that time, the first plane, serial number 3001, occupied position 2 on the production line. The aircraft soon was moved to the final. A preservative was added to the engine fuel system until actual engine runs could be accomplished on the flight lines. The engines were turned by air-ground power for the pickling process. All engines were installed by mid-February. Before the plane left the production line, installations of personnel seats and equipment were checked to check the operation of different systems and equipment preparatory to flight. The first production C-130 took off on its maiden flight on April 7, 1955. Only about 800 feet of runway were required and found to be satisfactory. The seats were removed and special first flight test equipment was installed. The first aircraft was then moved to the engineering flight test department for flutter and vibration tests. By late March, fueling operations and tests had been completed on all engines. High-speed taxi runs were made